Today I want to review a little Algebra 1, which is graphing a parabola from vertex form. Should have spent a little bit of time with this back then, but if you didn't, that's okay. We'll get you caught up today. If you did, this should be a nice little review day. Recall the vertex form of a parabola is a times the quantity x minus h, quantity squared, plus k. Where our vertex, if you think about a parabola, it's going to be in this shape, either upside this way or upside down. The lowest point here, or if it's going the other way, would be the highest point. So that would be called our vertex. And we have a line of symmetry that goes through that vertex. So that if we fold it across, that line of symmetry is going to look exactly the same on the left and on the right. So our vertex is going to be this h value plus k. So something you need to remember is if this was a plus h in here, the vertex would be a negative. So we're always going to take the opposite of what's with x here, and then our k value. A is going to tell us how it opens. If a is positive, we know it's going to open up. If a is negative, we know it's going to open down. So if you want a set of steps, here you go. First thing we're going to do is find the vertex and plot it. Then we're going to plug in a number to find a second point, and that number that we're going to plug into is going to be an x value that's close to the x value of the vertex. I'll show you that in a little bit. Our third point we can go ahead and find by going across that axis of symmetry. So if we know this point here is 2 units away, we know it's going to be 2 units away over here. And then we're going to connect it with a nice smooth graph. So you will need some graph paper. Hopefully you've had time to get that, since I told you at the beginning of the year that you would need some. So I do expect to see these on graph paper. I want you to graph y equals the quantity of x minus 2 squared plus 1. So the first thing we're going to do is find that vertex. Our vertex is going to be taking the opposite of what's with x. So we have a negative 2 there. Our vertex will be at 2. And then we're going to take the number that's by itself, 1. So we can go ahead and plot that point, 2, 1, on our piece of graph paper. We can now go ahead and find a point, another point that's close to that vertex. So what I like to do, you could plug in 1 or you could plug in 0. Those are pretty close. You could either plug in 3 and 4. So it depends on if you want to come to the left or to the right. If we can plug in 0, it's really a nice number to work with, but 1's not too bad either in this case. So if we were to plug in 1 into the original function, we find f of 1, which is going to be 1 minus 2 squared plus 1. Simplifying this, we get the quantity of negative 1 squared plus 1, so that gives us 2. So I know the other point, another point would be at 1, 2. Since I know I have my axis of symmetry that goes through that vertex, I know that if I'm 1 unit away from the axis of symmetry on the left, I have to be 1 unit on the right. I then can go ahead and draw in a nice curve. And there's a nice graph of that function. In example 2, we're going to see something a little different happen. Here we don't have a number with x, so how do we show that we have nothing in math? And that would be the existence of 0. 0 means nothing. So our vertex is going to be the opposite of what is with x. Goodness, get that out. Since it's 0, we can leave it as 0. There's no such thing as a negative 0. And then 3. So we go to the point 0, 3. And I can go ahead and find another point. I like to keep positive numbers, working with the positive numbers, and not go to that negative. So if at all possible, plug in a positive number. In this case, we can plug in 1. Not always going to be 1, but as long as we're around that vertex, we'll be good. So I can plug in my 1. I get 1 squared plus 3. So that gives me the point of 4. So I know the point 1, 4 has to be on that graph. Since my line of symmetry goes through the origin there, I know I can come across and pick up my other point and draw in a nice graph. And there's that parabola. Notice both of these open up because our a value is positive. Recall we can plug in a 1 there if you wish and show that that a value is a positive 1. So it tells us that it opens up. In our next example, we're not going to see a positive 1 a value. So in this example, we have a -2. So that tells us that it's going to open down. How is it going to open down? Well, we can go ahead and go through this and we'll see. So our vertex here, we have the opposite of what is with x. Can't say that today, can I? So -2. And then we have nothing out here. Again, to show a nothing, we put a 0. So we have our vertex at -2, 0. We can go ahead and find another point. We can plug in -1. We could plug in 0 if you want. In this one, I would go ahead and plug in 0. So if I plug in 0, we get -2 times 0 plus 2 squared. So we get -2 times 4, or -8. Notice we get quite large once we get farther away from that 0, or that vertex. So we have 5, 6, 7, 8. We have that point there. Here we're 2 away from the vertex, or from the axis of symmetry. So we're going to be 2 away on the other side of my axis of symmetry. So drawing in my graph, there would be a nice graph. And could you use 1? Of course, or -1. You could use -1. That would get you a little closer to the vertex. It's quite up to you. I like to use 0 myself, if at all possible. So here we have 1/2 x minus 1 squared minus 2. So our vertex, we're going to take the opposite of what was with x, and then our y value. So we have the point 1, -2. I'm going to find another point. So I'm going to find, in this case again, I can find my 0, f of 0. So I get 1/2 of 0 minus 1 squared minus 2. That gives me 1/2, -1 squared is 1. So I get 1/2 minus 2. So it gives us -3/2, or -1.5. So at 0, I can come down -1.5. We're going to have to approximate that value. That's okay. So we're 1 away from the line of symmetry again, so we can come over to the right 1 unit. And we see that we have this parabola here. So a couple things you should notice. If this is fractional between 0 and 1 there, we're going to have a nice wide parabola. Whereas if we had a number that was larger than 1 or -1, I say larger than -1, but actually it would be smaller, so it would be to the left of -1. We're going to see a tighter parabola there. Just a couple things that you hopefully see, not that we're going to test you on it just quite yet. All right, and then the last one here, we're going to write the equation of a parabola that has a vertex at 3, 4, and goes to the point of 5, -4. So what I like to do is go ahead and draw out what I know. So I know I go through the point 3, and 1, 2, 3, 4. There's my vertex. And I also know I go through the point 5, -4. So I know that this point and this point has to be on my parabola. This is my vertex, so I know I can't open up and go through this point. So the only way I can do that is to open down. So that gives me an idea of what my a value is going to be. It's going to be negative. I also know that the other half of this has to mirror this. So if I know that 5, -4 is a point I'm 2 units away, I'm going to be 2 units away from here as well. So that would be what it looks like, but I want the actual equation. Well, let's go back to that equation. We know that y equals a times x minus h squared plus k, where h and k comes from, you're right, the vertex. We know that h here is 3 and k is 4. So I know that y has to equal a times x minus 3 squared plus 4. But I need that a value. I can use this point, 5, -4, because 5, -4 has to satisfy this equation in order for it to go through that point. I have an x value and I have my y value. I know that -4 has to equal a times 5 minus 3 squared plus 4. I can go now and solve for a. -4 equals 5 minus 3 is 2, squared gives me 4, so I have 4a plus 4. Solve my equation, -8 equals 4a, so a has to equal -2. So I know my equation has to equal y, or y has to equal -2, which makes sense because it opens down. Remember that a value is negative. And then x minus my 3 plus 4, again, that comes from my vertex. And that gives you an example of writing an equation of a parabola. So hopefully it was a nice little review of being able to graph a parabola and then also to write an equation of a parabola. Good luck and have fun. If you have questions, give me a holler.